This is a video to describe the 5-header row approach to creating a code book for data. So this is some data from the Indianapolis use of force data, but this is a much smaller data set than the full data set. You'll notice there are only a few variables here, and I've taken a random sample of observations, and I think there are only 50 observations. This is a much smaller database than the full database that you would be working with. But this is useful for just demonstration purposes. So the first thing you want to do when using this method is finding the top row of data and making sure that you have at least 5 header rows above that. Now, sometimes, as is the case here, you will have at least one header row that's already present. I usually just go ahead and add 4 or 5 rows anyway, and then I can see if I need to retask any of the rows that are above there. I'm going to go ahead and insert several rows here so that I have 5 header rows. And this top row, I'm going to go ahead and leave with the information that came with the data set. Sometimes, like if you've downloaded data from Qualtrics or SurveyMonkey or some of those other things, this can actually be really useful information. So I like to keep that in that top header row. And the top header row is intended just to tell you about what the content is of the column. And in this case, that's exactly what these things do. So we're going to go ahead and leave that there. In this case, I'm also going to add, a column to the left. And that's going to allow me to just sort of indicate what's going on with these header rows here. So the top header row is going to be for information about my data. You can use a long form name for the data. So if I want to do something like identification number or incident, I could do something like that. So the idea is that this top header row is really just detailed information about what is contained in the data below. The second one is going to be level of measurement. And the third one is going to be units or coding. Fourth one is going to be notes. And the last one is going to be variable name. And this variable name is going to be what you actually import with your data. And that's how your variables will show up inside RStudio. So you're going to want to take some care with that. But these are basically what's going to be contained in your header rows. So for each of these header rows, I want to identify the level of measurement. Once I'm done with that, I want to identify whatever the units or coding are. If I have any notes about the variable, I would enter that in the following row. And then I'm going to use a variable name, ideally that has 8 or fewer characters, no spaces, and I generally prefer to stick with lowercase so that they're easier to type. When I'm doing my coding, I don't have to worry about capitalization. So I tend to keep those things in mind. So this first column, the ID number for the incident, this is going to be a nominal variable. And it's just as entered. Basically, this means that whatever was entered here originally is what the units are or how the coding is working. And then I would include any notes here. I don't really have anything to say about this one. And then here I'm going to call this incident ID. Now you'll notice that's more than 8 characters, which goes over what I suggested. So I might call it something shorter like incident ID or something like that. But you want it to be something where you are going to know exactly what is contained in that without having to look at it, and ideally without even having to look at the code book. If you go over the 8, that's okay. You just want to keep it as short as possible. It makes it easier to code and makes it friendlier to lots of statistical software programs, some of which prefer shorter variable names. Okay, so now we're moving on to this division variable in column C. Level of measurement, let's just kind of look through here and see what we've got. I can see an operations division, an administration division, And then if we kind of scroll down here, I can also see a Homeland Security division. So these are not in any kind of hierarchical order or easy ordinal order. So this is going to be a categorical variable. And because these are still in words, we can change that if we want to in R, but we're not going to change anything here in the data with an Excel. We're going to do all of that data cleaning and editing inside of R. So I'm not going to change any of that. So there's no coding going on here. So I'm going to call this as entered as well. I don't have any notes here, and I'm just going to call this division. That is just fine. Let's check out district. I can already see that there are more than 2 district options, and these can't be ordered either. So this is a categorical variable. And these are also as entered. I'm just going to copy and paste that. And this we're going to call district. All right, now we're on to disposition. So we're looking for level of measurement here. And if you scroll through, at least in this short sample, so we only have 50 observations here, but we're only seeing either blank or in compliance. So I'm going to list this as a binary variable because there are 2 options. It's either in compliance or it's blank, although I'm not sure what this blank means. So here in my notes column, I'm going to say find out what blank means and binary if in compliance is one category and blank is the second. And these are also as entered. And we're going to call this disposition. Beautiful. All right, so now we're at arrest made. And of course, this is whether or not there was an arrest made in the given incident. And as we scroll through this, we can see that there are exactly 2 options, true and false. So this is binary. And these are going to be as entered. Again, because there's no coding going on here. You'll see in a minute what coding looks like. But here, we're just going to count whatever is entered here. And here it's just true and false. And I don't have any notes here, so we're going to call this, let's just call it arrest. Okay, and we're moving on to the last 3. So this variable is whether or not a resident was hospitalized as a result of the incident. And you can see that it's listed here in 0s and 1s, and there are no other options. There are some blanks, but there are no other options besides 0s and 1s. So we're going to treat those blanks as true blanks as opposed to over here where we thought maybe they actually meant something, like maybe not in compliance, just based on what we saw in the variable given these 50 observations. But here we have a binary, and now we need to enter what these codes are. So here we have a 0 equals not hospitalized, and a 1 equals hospitalized. Now you'll notice that the convention is to indicate that a 1 is a yes and a 0 is a no, or 1 is true and 0 is false. And so it's useful to name the variable for whatever it is that yes means. So we're going to name this hospitalized. So that means if there's a 1, that they were hospitalized. And if there was a 0, they were not hospitalized. So here we have male resident. So this is a measure of sex or gender, but it's it's measured on a binary scale. So there are only 0s and 1s here. And the 1s are for male and 0s are for female, which we know because of the name of the variable. Although it's always good to verify that if you can with as original of data as you can to make sure that that is actually the convention that's being used. But in this case, I happen to know that that's the case. I'm going to call this a binary. And 0 equals female and 1 equals male. And again, these are the only two codes that are available here. You'll notice that some of them are missing. And you can't just assume because this is a gender or sex variable that there will only be two codes. You would actually have to double check that. But that is the case here. There are only zeros and ones. So we've indicated what the coding is, and we are going to call this male res. And our final category is resident age. And you can see here that this is an interval variable. It has both order and a unit. So interval. And the unit here is years, because 19 isn't just 19, it's 19 years old. 31 is 31 years old. 14 is 14 years old. So you can put years here, or you can put years old. Either way is just fine. And I'm going to put age resident here as my variable name. Okay, so now we've gone through, we've created this 5 header rows of content above the actual data. Some of this was already here in the data set when we started, and some of it is data that we added. So what we're going to do next is I'm going to come down here to the bottom and use this little plus sign to make a new sheet. And I am going to copy and paste all of these header rows, but I'm going to do it by transposing them. So I'm going to use Control-C to copy that. I'm going to come over to sheet 1 and this top little item here, and I'm going to right-click. Now when I right-click, it brings up a menu for me. And I'm going to choose Paste Special. And none of these special paste options are special enough for me. So I'm going to paste special again. And I'm going to click this little tick box down here that says transpose. So this little box needs to be checked. What that's going to do is that when I paste my header rows, instead of pasting them horizontally, it's going to paste them vertically. So there we go. Those are our header rows. They look a little different from what we had before. And let me just make that a little bigger so you can see what's going on here. If I spread this out a bit, you can see that I now have a set of information about my data set that makes it easier for me to look at what the contents are of each variable. So here's my variable name on the right-hand side, and then I can also see all this information about those variables. And so this is a very printable format. It's an easy format to update and pay attention to, but I also know that because I built it right next to the data, that I was quality checking it the entire time that I was building it. So now as I go through and work in R, I'm going to want to keep up these notes inside my R code because I'm going to be changing some of these variables. But if I ever share this data with someone else and give them the original data set, and I give them the code book, and I give them my code, they're going to know exactly what they had at the beginning. And if they choose not to use my code, they'll know exactly what the contents of my data are. And they'll also know any concerns or questions that I had about it. So this is a really useful codebook format. And usually I actually save out this version where I have the data and the codebook and the flipped codebook, the transposed codebook. Then I save all of that. So I'm just going to rename my sheet here, codebook, so that I have that. And I'm going to save this as a file. I'm going to save it in my downloads folder. And I'm gonna save it the way I had it before, but I'm going to say with codebook. And then I can go ahead and save. All right, so there's one more step now that we're going to do so that we are prepared to upload data into R. Now, R can actually take data out of an Excel spreadsheet, even if there are multiple sheets in that spreadsheet, but it's important to understand how to export something as a comma-separated values or CSV file. So we're going to go over how to do that really quickly. So again, I'm going to start another sheet here, and I'm going to call it data only. And I'm going to go back over here and I'm going to copy everything. So I just did Control A so that I could select everything, and now I'm doing Control C, so that I can copy everything. You do want to make sure that you've for sure got everything. If there are blank rows in your data, sometimes it won't select absolutely everything. So you want to make sure that that is working correctly and pay good attention to that. But I've got everything here. I'm going to click over to data only and paste all of that information. So now I'm going to take my whole data set, and let me just make that bigger again so you can see what's going on. I'm going to now prepare this for upload. And to do that, I'm going to get it in the format that I want it for my comma separated values file. So I am going to, now that this is my data only sheet, I'm going to delete all that work I just did on the top. And I'm only going to save the data and these variable names. So this is going to be my only header row as I import it into R. So typically at this point, I would save it again. So I've got my original data with the codebook, I've got my codebook, and I've got a data only tab. And I would save it this way. So I'm going to do Control S, go ahead and save that. You can also do that up here with your save menu. And now I'm going to save only this data sheet. I'm going to discard my codebook, and I'm going to discard my codebook with the data in favor of just a data only sheet, but I want to save it as a CSV file and obviously with a different name. So I am going to save this as, save it in downloads again, and this time I am going to call it something without spaces, and I want to avoid numbers at the beginning, but I'm going to call this Indianapolis force data import. And you'll notice that it has this file extension XLSX at the end. We need that to change because for import, even though R and RStudio can handle Excel, it is good practice to make sure that you've got a comma separated values file in case you're not giving it to someone who's got a program that can handle Excel files. CSV is a format that is very transferable from one data analysis program to another. So it's important to at least know how to do this, even if you don't ever use it again after this. So there you go. Again, I've just clicked Save as Type, and I went down until I found CSV, comma delimited. So I'm going to choose that, and I'm going to save. Now I'm going to get a couple of warnings here. Warning 1 says this file type does not support workbooks that contain multiple sheets. That basically means I'm only going to be saving the active sheet. So I need to double check this is actually my data sheet that I'm trying to save. And in fact it is, and I'm okay with that. So I knew I was going to discard my codebook and my data with the codebook. I've got those saved elsewhere, so I don't need to worry. So that is okay with me. And then it's also going to warn me that I'm going to be losing some features. And those specific features are things like, you can see that there's some bolding going on up here on my top row. That's going to disappear in comma separated values. If I had any highlighting or any like formulas or anything like that, all of that would be lost with the comma separated values file. But I am okay with that, so I'm going to click yes, and it's done.